Imagine working in temperatures of 1,250 degrees Celsius. Or maybe having to drill thousands of bolts into a concrete shaft that's over 300 meters high. Or coping with the extreme pressures and darkness of the ocean depths just to do your job. These and many others are examples of the type of work that we as humans want to avoid or simply aren't physically able to do. After all, there are plenty of better ways that we can use our unique skills. And this is where robots can play a vital part. What's more, robots are rapidly advancing to take even more of the danger and drudgery out of routine tasks. I'm Fran Scott, presenter, maker, and all-around engineering fan. And in this episode of the Robot Podcast from ABB, we're going to get an insight into robots at the extremes. From those that can handle extremely hot temperatures in a factory forge, to submersible robots working at extreme depths in the ocean. Not to mention the robotics and AI systems conquering extreme heights when installing lift shaft transport systems for elevators. But before we get hot under the collar or take a deep dive or even scale the dizzy heights of these amazing machines, let's first get a general view of robotics and how they can work alongside us to improve accuracy and reduce risk whilst working at the extremes. Susanne Timsjo is Marketing and Sales Manager at ABB Robotics, and she shares with us how robots and humans can work together.
The first robots were invented in the 1960s. And then in the industrial robotics domain, we usually talked about the first electrically process-controlled robot that was invented by ABB Robotics in 1974. And it has been designed and has always been designed to be an attractive solution for dangerous jobs. I mean, robots, they don't get tired, they don't need daylight, do not feel pain, they do not need oxygen. So what really drives robot technology and the development is to save human lives and to create a better work environment for people. Looking back, the first robots were introduced to the automotive industry, driven by high volumes, little variations. It was very much heavy lifts, paint type of applications that were first applied using robots. In that type of industry segment, it made sense to utilize robots because as we look at it today, no human can build a car in 1 minute. Robots is a fantastic tool, and that can also be utilized in other industry segments. There's a lot of industries that don't use robots today. And why is that? Yeah, because you need to have more flexible automation. So that is a trend that also is linked to what is needed to provide robots in extreme environments and what is needed to be able to utilize robots in more industry segments.
So what you're saying, and this is something we're familiar with in the Robot Podcast time and time again, we can use the robots within manufacturing, but also we can use robots to, I suppose, explore and understand the world in ways that would otherwise be impossible, right?
Yeah, and I think it's always good to think about what we cannot do as humans. Maybe the robots can come in and support and help us. And if you think about working in extreme hot environments, working in places where there are toxic gases, maybe melted metals. It can also be in environments where there's work on extreme heights, for example, or extreme depths. When we have tasks that it doesn't really fit the human, then we can utilize the robot to do the part that we don't want to do, more or less.
There's the phrase, isn't there? The 3Ds, the dull, the dangerous, and the dirty. There's also another D, isn't there, which is delicate. And what examples do you have of robots doing delicate work?
When it comes to delicate, for me, that is more like precise type of work, where the robot is more accurate and precise than we humans. So it can do things that we are not capable of. So it can be like laboratory work, it can be very small parts type of manufacturing, surgeries. So very precise type of work, not suitable for us.
I've been in some factories in the past where it has been largely women because women tend to have smaller hands and those smaller hands can solder smaller objects. What about not subjecting anybody to these conditions?
Yeah, and I really like that example as well, because when we invented the Yumi robot, which was the first inherently safe collaborative robot, the idea was born from being in different electrical type of manufacturing industries where there was a lot of female workers doing this very small part type of assembly, and their work life length was approximately 3 years because they were completely destroyed in their shoulders and necks after this very heavy type of work. So that's actually also how our Yumi robot was born initially.
You have a great example of an area where robotics could play a key part in improving things in life, don't you? I've heard that they could be used in unmanned mines.
Yeah, that's an example. And it's also linked to my background because I have been working within the process industry, more or less. And if you think about mines, it's a true asset of raw material, and it's something that we, in a way, take for granted. In mines, it's a lot of work above earth, but it's also a lot of work that needs to be done underground. The mining companies, they do a lot to have a good work environment, safe environment, but still it is a challenge because going down under mines is very small spaces. Workers need to navigate through narrow tunnels, shafts, drifts, and maneuver. And then it's also very dark, also high temperatures. There's noise, vibrations, dust. So if you think about all these things, that's a perfect part where you would like to explore more automation and also the use of robots to do certain type of the tasks to get out the raw material.
Because you could think of extremes as being volcanoes or space, but actually there's a lot of extremes that are much closer to home than we think. So what does this offer in terms of opportunities for those who manufacture those robots?
The growing demand for robots in extreme environments and tasks is significant opportunity, I would say, for manufacturers like ABB. More industries will also start to adapt the robot technology, and that in the same time will be increasing demand for robots that can operate in such environments to perform specific tasks. So manufacturers that are able to develop robots that effectively can work in extreme environments will be in high demand.
When you are thinking about these robots that can work at extremes, where do you see them going in the future? Where do you see them being used?
Space explorations, like use robots to explore Mars or other planets. In like the aftermath of natural disasters like earthquakes, hurricanes, floods, maybe we can utilize robots more in that context as well. It's definitely an area that is interesting to explore. It's super exciting.
Thank you to Susanne Timsjo. Now let's kick off our journey and meet these robots that are working at the extremes. And our first one is doing some jobs at extremely high temperatures. Robert Kiefer is a robot specialist from the business unit of German industrial engineering and steel production company Thyssen Krupp.
We are a forging line. That means pretty heavy stuff. We produce crankshafts for cars, crankshafts for trucks. And since 2 years, we started to produce front axles for trucks. That's pretty a harsh environment, pretty heavy, pretty hot. For that, we need strong robots to handle the stuff.
They're made of steel, right?
Made of steel. And the steel gets heated into an oven. It's a temperature of 1,250 degrees, so pretty hot.
Pretty hot. How on earth are these robots designed and built to withstand those temperatures of upwards of 1,000 degrees Celsius?
The grippers that are fixed on the robots, they are pretty massive, they're pretty robust, and to resist the heat. And the robots, they have special codes, and these helps us to control the temperature And besides the coats, some robots, they have protection shield to handle the harsh environment. A little bit like a heat resistance shield, pretty heavy texture, gold and silver film on it, that they reflect the heat.
Describe why only robots could do a job like you're describing. What is the environment like at the innovative coalface of making these crankshafts?
It's dirty, it's foggy, and of course it's a safety aspect. The parts we are handling are pretty heavy. So the smallest crankshaft to start with 10 kilogram maybe, up to crankshafts for trucks with a weight of 200 kilograms. Front axles can have a weight of 250 kilograms. And there's no way these heavy parts could be handled by a worker in the cycle time that we need. So robots are the strongest, quickest, and most safe solution for our applications.
It sounds brilliant. So how many ABB robots do you have working for you?
So right now we have in our plant 230 robots, and we started 11 years ago when I started my career here at Thyssen Krupp with 140 robots. So that means we increased our number of robots in installation for more than 50%.
And how has that manifested itself? What improvements have you seen?
So the improvements in our factory, first and foremost, is the safety of all the workers. You know, when you work in such an environment, it's really dangerous. So the robots are a huge help. So every robot that we install makes our working environment easier, healthier, and more safety.
How many steps are there in the production process, and how is it all choreographed, which, you know, a production process needs to be to make sure that it all works smoothly at these exceedingly high temperatures, because you're working with molten metal. You know, you've got to do things fast and precisely, haven't you?
Absolutely. So in our production, there are several steps, starting with soaring, heating, forging, cooling, the final control, and at least, of course, shipping. So we have so many applications like handling, gripping, tracking, conveyor track, spraying, surge movements for automatic gripper adjustment, for example, torque surge, multi-move, and so many applications our robots do for each our cycle time. All our cycle times are between 7 and 25 seconds. For this, heavy parts are really pretty quick. And mention the part quick cycle time plays a huge role in the functionality of the robots.
Where do you see the future of robots when it comes to working in extremely hot environments? Where do you see this all heading?
For the future, not only robots will play a huge role in automation, I think robots will have a huge impact in service and logistics too. They get better and better every day. So I saw it for myself the last 11 years when we started with older robot models and old robot controller. What the new generation of robot controllers doing today, it's really impressive. I think it's pretty important to create an environment where people can work 60 or 65 and they still work, that they have a workspace that are really comfortable and adequate for them. And I think we're on a good way on that.
That was Robert Kiefer, a robot specialist from the business unit of German industrial engineering and steel production company Thyssen Krupp. And what I loved about our conversation, that is obvious now I think about it, if you are going to use robots in extreme environments, the robots themselves, of course, need protecting. According to Oxford Economics, so that's the world's foremost independent economic advisory firm, it's estimated that by 2030, robots could potentially be used in 20 million more manufacturing jobs worldwide than they are now. And many of these jobs would be in environments that are not safe for humans. So there's no doubt that robots can do some amazing things that are at the edge of our own capabilities. From robots, for example, being used to decommission nuclear reactors, or robots working at extreme heights. And that leads us on to our next guest. there's one company that uses robotics and AI to do a very dangerous job, but one that allows us all to travel up in the world in the comfort of a fast-moving box. Faruk Osmanbasic is the product manager of Schindler, the elevator lift corporation, and he has been telling me about RISE, so that's the robotic installation system for elevators. But before we get on to RISE, let's first find out how this job is done without robots.
During the traditional installation process, the people are either working from a fixed installed scaffolds or using temporary movable working platforms to move to the shaft. First, they have to measure the correct position and then to attach different stuff where the elevator is installed. Depending on the building, on the elevator, they will be more than 1,000 bolts per one elevator. And especially in the high-rise buildings, we have multiple elevators, so they will be several thousand installed bolts for a group of elevator. During the construction itself, the shaft where the elevator is allocated, it's a quite harsh environment for working. It's dusty, it's cold or hot depending on weather, and as well the drilling itself, it's quite noisy and not so comfortable to be there. If you have very high building with the sky lobby, often you just have the first floor and the sky lobby floor, which could be several hundred meters far away. And if you are inside there and would like to have a break, it's quite far away.
So that's how it traditionally happens, but robotics are changing that, aren't they? So Faruk, could you tell us a bit about this system that you've pioneered and how it works? Please share what that's all about.
Before we start the job, we are uploading the layout of an elevator on the RISE system, and the robot hoisting device is installed on the top of the shaft. Then we are bringing in the robot to this hoisting device, and the robot is working fully autonomous there. So the main 5 steps of working are autonomous vertical moving. So RISE itself position itself on a correct working position and bracing there to have secure place for work. After this, it's checking surface for different obstacles. On one side, not to have collision, and other side to guarantee proper quality of the installation. After this, the third step, scanning the wall itself for iron bars, which are inside, so to avoid drilling on iron bars. Then it's drilling the hole, and then after this, putting the anchor bolts where we attach the elevator afterwards. Besides these 5 main tasks, the robot is as well able to exchange the used drill bits in case it is needed or it's worn out.
That is genius. So obviously there's an advantage in this in that you don't have to have humans doing that repetitive tasks, but what are the other advantages of this system? And is there a limit to how high it can go?
As example, we had in Warsaw Tower in Warsaw, Poland, 205-meter shafts with 720 bolts per shaft, and there we installed 13 units of this. As well in Uptown Tower in Dubai with 316-meter shaft height, and in Shanghai the shafts up to 350 meters height, where 15 of high-rise elevators were installed. And this can be done, as example, overnight. If the local regulation allows this, we can work over the night where people are not necessary. People can go home, and when they are coming next day, they will find empty robot. They will put additional material in, and the installation continues.
Amazing. So the workers go home, the robot goes in, does the work that the workers would have done in the day, and then the workers come back and basically just top up the robot, and they can get on with other stuff that's a bit more human friendly, let's say.
Up to 3 times faster than human executing this drilling and bolting process.
I suppose there are other advantages to humans not having to be subjected to those conditions, isn't there?
Sure. In addition as well, the tough and repetitive non-ergonomic installation steps will be eliminated, and exposure to the silica dust is minimized with this step. Summarized, as a result of all this, the risk for accident is lowered. We create better conditions for human working and attract as well more new people joining our industry.
So I suppose that makes it more safe during the lift or elevator construction. But how do you monitor the work that the robot has done and make sure that the work it's done meets safety requirements?
This is a very, very good question. The robot work itself can be monitored remotely with multiple cameras we have installed on the robots, and as well different sensors measuring different stuff. Let's say in the same building or even remotely from office building, we can check, see the progress and as well what is the status. As example, soon we have to prepare additional bolts to fill in.
Gosh, how do you then see the future of this robotic technology in particular? Where do you see it next being used?
I think in future we will see more and more robotic applications on construction sites, which is today not yet the case. Because of all these reasons we mentioned before, less exposure of human being to risk, doing repetitive work and all this stuff. And I think as well robots together with other technologies like connectivity, AI, and the need for better and safer environment for human beings will be the main driver in the future.
Faruk Osmanbasic, a product manager of Schindler, the elevator lift corporation. Wow, Rise is immensely clever, not only doing a dangerous job that perhaps humans shouldn't be doing in the first place, but also doing it in a way that it can monitor, in a way that humans just wouldn't be able to do. So from extremely high, we are now heading in the opposite direction because our final destination is to the ocean, where deep in the waters of our planet, there are robots doing things under immense pressures to monitor the ecosystems and help protect Earth's precious marine life. Kakani Katija is a bioengineer, and she works at the non-profit Monterey Bay Aquarium Research Institute, studying ocean life.
My group is the Bioinspiration Lab, and it's a group of individuals that have imaging, robotics, visualization expertise to try and tackle these issues or challenges around observing life in the deep sea.
What are the challenges of working in the deep sea, and how are robotics and robots helping you to overcome some of these?
The deep sea is not a place that I can just swim to. Very dark, very cold, high pressures. So these are environments that really, robotics thrive. Being able to have a vehicle in the depths of the ocean, basically serving as our eyes or, an extension of the kinds of observations we need to make is really, really important. We are doing most of our investigations in water that's 4 kilometers deep. In those conditions, you're talking very, very, very high pressures, temperatures that are near zero, completely black. And so we have to bring everything down with us, power, communications, illumination, in order to do the kind of work that we do.
So those conditions you've described, they sound very perfect for robots, but what type of jobs are you having them do?
Observe animals and understand their behavior, their biomechanics, their movements, how that might affect their ability to survive. But I think also understanding what those mechanisms are that make them successful so that we could potentially reverse engineer what they're doing and apply it to other technologies. So that includes having a platform that gets your eyes, so to speak, right on the animals or the objects of interest. That also involves bringing along with you instruments that can capture, whatever feature it is you're really interested in. So in our case, we're an imaging lab, so we have a number of imaging systems that we've developed that allow us to quantify, animal movements or animal shape. And then we also have robots, or at least needs for robots to either repeat those observations or continue observing that one thing for a very, very long period of time.
And I've heard you do some quite interesting manipulation with the data that you collect.
One example is a deep PIV instrument. PIV stands for particle image velocimetry, but what it is a laser illumination system that, when coupled to our imaging system, can create these planar views. So think of a X-ray or an MRI where you can collect individual slices of an object and then later turn that into a 3D reconstruction.
And with this, we're not necessarily talking about manned submersibles, are we? We're talking about robots that are autonomous, that go down by themselves, either controlling themselves or controlled by you further up the ocean.
It doesn't really matter if you have an autonomous underwater vehicle or if it's a remotely controlled underwater vehicle, a crewed submersible. The idea is that some of the instrumentation we create, it can be integrated on any of these platforms. But what we do a lot of our development on are remotely operated vehicles. They are piloted from people sitting at the surface. And then we also use autonomous underwater vehicles, the bullet-shaped or torpedo-shaped that you may have also come across and seen.
And what sort of advances have you seen technologically with these robots?
Oh, many. Over time, it's become really clear that while these massive remotely operated vehicles give you a lot of information and capabilities at sea, they're unfortunately not a scalable solution when you're thinking about underwater robotics. Only a few of these vehicles exist around the world for deep sea research. And so that already is pretty limiting in terms of who gets access to these vehicles. The bottom of the ocean is this massive volume, 97% of the habitable ecosystem on our planet, and we've probably only observed about 1% of it. That's a big gap to fill. How do you do that? And really, you can't be expected to be able to do this with very, very expensive vehicles. This is, I think, one of the big driver for technological advances that we're starting to see in deep ocean robotics is moving towards systems that are scalable, that not only allows us to do lots of observations or monitor vast swaths of the ocean, but also do it with a lot of other vehicles, more vehicles, take fewer human input. So that's where I think we're starting to see fully autonomous vehicles. Also the importance of being able to loop in humans when we're needed, run a mission, but then at the end of the day, if there's an issue or a challenge or something is going wrong, or the vehicle comes up against something that is interesting or novel, you need to be able to indicate to your human operators that that is what's happening. And so, advances in that area.
When you say fully autonomous vehicles, are they programmed in a certain way or are they using AI?
It could be a combination of those two things. There are some algorithms that are running on these vehicles that allow the vehicle to make some smart decisions when it's coming across a new feature. But there's a whole suite of algorithms now that really enhance the capabilities of these vehicles. And you're starting to see this a lot in the terrestrial space, right, with artificial intelligence and machine learning. And so what we're starting to see is inclusion of these kinds of algorithms on these robotic vehicles to help improve our autonomy on these robots.
So in terms of the development that we've had over the last 10 years, obviously it's accelerated. What do you see happening in the future in this field or ocean of study?
Oh, man. Crystal ball gazing time. I would like to see smarter robots. It could be lower cost systems that are more easily deployed by a lot more people. It could be data infrastructure that brings people in so they can see in real time what these autonomous vehicles are seeing and observing. But it's going to have to be a combination of all of these things to come together if we really are meeting the needs of monitoring in the ocean.
Kakani Katija, a bioengineer who works at the Monterey Bay Aquarium Research Institute, studying our ocean life. And gosh, what an episode it has been. And we've been high, we've been low, we've got hot. And it's amazing how we can use robots in these environments so they can take us humans out of them. But that is it for this week. Thank you again so much to my guests, Susanne Timsjo, Robert Kiefer, Faruk Osmanbasic, and Kakani Katija. Next time, we're heading off to South America, where robots are doing their bit by helping to replant deforested areas of the Amazon. I'm Fran Scott. The Robot Podcast is a Fresh Air production for ABB. The producers are Seaman and Izzie Clarke. And don't forget to follow now for free wherever you get your podcasts so you never miss an episode.
Part of the ABB Decoded series.